Making a solution by dilution is a very common technique in chemistry. In this video, I'm going to show you two things. One, how to do the calculations to calculate what volume will be required of your stock solution to make your more dilute solution. Second, I'm going to show you the techniques to making that solution in lab with the equipment that you have. What volume of a 0.500 molar sodium chloride solution is required to make 500 milliliters of a 0.100 molar sodium chloride solution? First, we have to learn how to use the dilution calculation formula, and next we have to learn how to make the solution from the lab equipment in a chemistry lab. Making a dilution, or making a solution by dilution, it's the addition of a solvent to decrease the concentration of the solute in a solution. It's concentration 1 times the volume number 1, which is usually the more concentrated or the initial solution. And then it's going to equal the concentration of your second solution times the volume of that second solution, which typically is your more dilute solution. You just have to make sure that your concentration units on both sides are the same and your volume units on both sides are the same. So what does that really mean to dilute something in that the concentration changes, but the amount of solute does not? That's what makes this formula work. So when I pour in my more concentrated solution into this container, and then all I do is add more solvent, in this case water, I haven't made the moles change or the amount of solute change. I have only changed the total concentration because I have more solvent. The most common version of the C1V1 equals C2V2 equation is using molarity for your concentration. Again, the 1s are the initial or the more concentrated solution, the 2s are the dilute solution. Again, why this works is because the moles of solute is equal on both sides of this equation. The moles of the solute that you took from the more concentrated solution is going to equal the moles in your more dilute solution. Okay, so keep in mind, make sure that you write this down, that the moles of the solute remains constant. You just have more solvent added to dilute the solution. The other thing I would write down are the definitions of the molarity 1 and 2 and volume 1 and 2. So again, I would write down that the molarity of your initial solution is the more concentrated one. It's also called a stock solution. The volume of that solution is the volume you're going to take out that we're going to very accurately measure in the next part of this video, where I'll show you the demonstration of how to make a solution by dilution. Then you're going to have a new molarity for your less concentrated or your dilute solution and a new total volume for that new solution that you're going to be making. The first step of making a solution by dilution is knowing the new concentration, the diluted concentration you want to make, which is 0.1 molar in this case, sodium chloride, and that's the M2. The volume you want to make of that new diluted solution, which is the V2. And then you also need to know the stock solution, the more concentrated solution, what kind of molarity does that have? In this case, 0.5 molar sodium chloride. And again, the moles are going to be equal on both sides. And of course, the substance, the solute, has to also remain the same. So the first thing I would do is write down your given, or what you know. And you know you're going to start with a 0.5 molar sodium chloride solution. You do not know the volume we need. And we're trying to then make a 500 milliliter 0.1 molar solution of sodium chloride. So there's your dilute solution. So the first thing you're going to need to do is take this above equation and divide both sides by M1 so that you can isolate for V1 on one side and all the other variables on the other. I'm going to leave the milliliters the same. I'm not going to change it because my volume then here will be in milliliters and it'll make more sense. So all I got to do now is just put in the numbers and solve. So you're going to have your 0.100 molar solution of sodium chloride, and it's going to be 500 milliliters, and I'm going to leave that because I'm going to solve for it in milliliters because it will be a smaller volume. And then I want to then just divide by the 0.500 molar NaCl, the more concentrated solution called the stock solution. So you just take 0.1 times 500 and divide it by 0.5. And we get, this is going to be 100 milliliters on the dot. So step 2 and 3 are going to be grabbing the equipment that you need. I've grabbed all the necessary equipment we can use to make a solution by dilution. I also have some optional glassware that is more accurate, and if you have it in your lab, I would use it to make your solution. However, in this video, I'm going to be using the most common pieces of glassware you would have in a high school chemistry lab. First, you must have your 500 milliliter volumetric flask. This is the new total diluted volume for the problem that I'm going through. There's a temperature that shows you that it's accurate at 20 degrees, and it shows you the uncertainty is 0.41 milliliters. So that tells you how accurate this volumetric flask is. Next, you must have the stock solution that you're going to be measuring and then diluting, in this case the 0.5 molar sodium chloride. Have a beaker ready and maybe a plastic pipette so that you can put that into a specific separate container. Never measure out of the stock bottle or put anything back into the stock bottle when the lab is over. You need solvent. So our solvent is distilled water. We're going to have that. Next, you'll need something to cover your volumetric flask to invert it and mix it. Maybe a funnel to help transfer the liquid. Safety goggles, and the most important is how are you going to measure this 100 milliliters of our sodium chloride stock solution? This is where the options happen. Number one, if you have these volumetric pipettes, I would recommend using these. This one is a 50, so I could use this twice, and it accurately measures 50 milliliters and only 50 milliliters, only one volume, but it does so very accurately. I have a 25, 10, and 5 just to show you that there are smaller versions. I've also grabbed a pipette, so if you had smaller volumes, this won't work with ours because this only goes up to 10 mils, but this has markings every 0.1, so it's also very accurate if you have a graduated pipette. Next, in every lab, there should be graduated cylinders, and this is actually the piece of equipment I'm going to use because everyone has a graduated cylinder. Now, the problem is these are only marked every 1 milliliter, so it won't be as accurate. There might be a chance that you have smaller grad cylinders that are marked every, again, 0.1 milliliters, but for us, with 100 milliliters in my demonstration, I will be using the 100 mil graduated cylinder. However, again, this 50 mil volumetric pipette would be the best option if you have it. I have kept the equipment I plan to use to make my solution by dilution, and I'm using, again, the most common equipment that you'd have in a chemistry lab in high school. First thing is to take your stock solution, pour a small amount into the beaker that you're going to pour more into in just a little bit. Next, swirl it around so that any water or any other things that might be in that beaker, you can remove them with your stock solution. If it's a safe solution like I have, I just poured that into the sink. Next, pour into your beaker more than the volume you're going to measure. So for example, for me, I'm going to pour in over 100 milliliters because I need to measure exactly 100 milliliters. Next, you'll add the stock solution into the piece of equipment that you're going to be using to measure. So you'll want to rinse your measuring equipment also with that stock solution. So in this case, I'm using the graduated cylinder, which is the most common piece that you'd have in a chemistry lab. Again, I poured that into the sink because that is a safe solution. If not, you'd have to use a waste container. After that, I'll be grabbing my grad cylinder and filling it to close to the line that I'm looking for. In my case, again, it's 100 milliliters. So I'll be filling this to close to 100, but below it, so that I can get the grad cylinder at eye level and fill it exactly to the 100 milliliter line. With your piece of measuring equipment at eye level, add small amounts of the stock solution until you are exactly on the line that you want to measure. In my case, again, it's 100.0 approximately milliliters. So I want my meniscus to be right on that top line so that I have exactly 100.0 milliliters to make my solution by dilution. The first thing you'll want to do is rinse your volumetric flask with distilled water and dump that out. That way you'll remove any water in there from the tap or any other contaminants that might be in the volumetric flask. Next, fill some of the volumetric flask before you add your stock solution. In this case, I will add it about 1/2 full because I'm only adding 100 milliliters. If you use a funnel to transfer your stock solution, make sure that you've also rinsed that with some distilled water before you start. Take your stock solution, pour it into the volumetric flask slowly so that you don't overfill the funnel, or you can pour this directly from the grad cylinder. Next, take a distilled water bottle and rinse the inside of the graduated cylinder so that you get all of the stock solution that you measured and that it is placed into the volumetric flask. You can do that a couple times for good measure. After you've done that, you can rinse down the funnel, the inside of the funnel. The next thing is to take your funnel out carefully and cover your volumetric flask. In this case, I'm going to be using parafilm, but some do have covers or tops. Then after you've gotten your stock solution in there and now you have your distilled water in there also, don't fill it to the line yet. Invert this flask numerous times to get a good mix of your stock solution that you measured and your distilled water. Once you have mixed that thoroughly, add distilled water until you get to the neck of the flask. Avoid the line, make sure you fill a little bit below that line. And then again, we need to get this flask at eye level to fill it directly to the line. So once you've added solvent until the neck of the flask, then slowly add distilled water until your meniscus is directly on that line. Slowing as you get towards the line on the volumetric flask. And you want that meniscus to be directly on that line. Again, you'll see bubbles. Those are not a chemical change. That's air that's in the solvent and the solution, in this case, being removed. So the next step is to cover it with parafilm, mix it, and see if it still remains with the meniscus on that line. Cover your volumetric flask one more time with a top or some parafilm. Invert it a few times to make sure that the solution forms. And if there is a lot of bubbling, meaning air trapped in the solvent and solute, in the solution that's formed, sometimes this meniscus will drop below the line. Then you just add a little bit more water until the meniscus is directly on that line again. So you can see that my meniscus did drop below that line. It's right there. So again, what you would do is just add a small amount of water, distilled water, to fill it so that it's back with the meniscus directly on that one line. And congratulations, we've made a 500 milliliter solution of 0.100 molar sodium chloride from a stock solution of 0.5 molar sodium chloride. Make sure when you're done and you're ready to clean up that you transfer your solution to a new stock bottle that's appropriately labeled. Clean and dry all your glassware and put it away. Last but not least, do not ever take any excess stock solution and put it back into the stock bottle. Either dump it down the drain, in my case, because it's just salt water, or put it in a waste container. But never ever take your excess stock solution and put it back in the original reagent container.